Hey guys, what's going on? Here is Notes 3. This is both for the Cal and the pre-Cal class, the upcoming ones. I tried to get this one in there before the 4th of July. I wasn't able to, guys, but here we go. It's July 5th. I hope you guys had a good 4th, and hopefully your tummies are full and all that good stuff. And let's get right into it. I don't see any problems on this activity. I think you guys will be fine. Activity 4, there might be issues depending on your experience with graphing rational functions, but we'll cross that bridge when we get there. We'll probably get there tomorrow. So here we go. Let's start. Simplify all this mumbo jumbo and write it a single fraction. Sometimes this is called a complex fraction, guys, because you have a fraction with a fraction, fractionception. Don't go to your professor and tell him fractionception. If you've never seen the movie Inception, you have no idea what I'm talking about. It's called complex because you have a fraction within a fraction. Of course, here you don't see that wording anywhere. I just typed it out just really quick. So here we go. So you have x plus a divided by negative 3, and I'm dividing by 1/5. So maybe in junior high you learn something like keep, change, flip. And you can do that here. It's the same thing. So I'm going to write x plus a divided by negative 3 times. So I'm changing that division sign to multiplication sign. 5 over 1. And that's it, guys. I just multiply it. So 5 times x is 5x plus 5 times 8 is 40, all divided by negative 3. Usually with this negative here, guys, I usually like to put it out in the front here. Negative 5x plus 40 over 3. But if you want to group it with the 3, that's fine. If you decide to bring it in, then you're going to have to distribute the 5x and the 40. So negative 5x minus 40 over 3. But you can leave it like this one, or you can write it like that. It's all the same. All right, let's continue, guys. So again, complex fraction here, I can do 2 over 1. Or you can just bring that 2 up to the 3x minus 4, however you like, guys. So here we go, x over 3x minus 4 times 1/2. I don't see anything crazy here. X times 1 is just going to be x. And then 2 times 3x is going to be 6x. 2 times 4 is going to be 8. And there it is. They didn't tell me to leave anything in factored form. So there it is, guys. And that's it. It says perform the operation and simplify as a single fraction. So I see negative times a negative. So negative times a negative is a... That's right. It's a positive. Way to go. Guys, I'm kidding. I can't hear it all. All right, anyways, let's continue here. 5 times 8, what's that, 40? So I'm going to write 40. And I just did that from, just 5 times 8. And then go ahead and distribute that 3 in the denominator there. 3 times 3x, that's a 9x. And then 3 times 5, that's 15. Negative times a negative is positive. I don't see anything there. I think that's it. And we're done, guys. Let's keep going. Let's see here. It says perform the operation, express your answer as a single fraction. All right, that's not a big deal. Common denominator, that's all you need. And you've been doing that since, who knows, like 3rd grade or 4th grade, whenever your teacher introduced you to common denominators. So I'm going to multiply the right term here, or the right, this 3/4 here, by x squared over x squared. So x squared over x squared is the same thing as 1, and anything times 1 is itself. I'm going to multiply the right one here, or the left term here, by 4 over 4. And when I do that, I'm going to have, let's see, 4 over 4x squared minus 3x squared over 4x squared. And now that the denominators are the same, I can go ahead and combine them. 4 minus 3x squared over 4x squared. And that's it, guys. We're done. Yay. Isn't that awesome? All right. I don't see any errors. I think we can continue. So let's continue. Example 20, it says the same thing. We're going to perform the operation again. So I see 10x squared, guys. So I see that I already have 5x. So if you already have a 5x, all you got to do is multiply that 5x by 2x. So take the left term here. I'm going to go 2x over 2x. And when you do that, you're going to get, let's see, 2x over 5x squared plus 3 over 10x squared. Excuse me. I messed up there. That 5x should be a 10. 5 times 2 is 10. And then from there, you're just going to add them up. 2x plus 3 over 10x squared. I don't see any issues that we fix the the 10x squared in the denominator there for the first term. I do not know why I said 2x times 5x was 5x squared. My apologies. My bad. I hope no one's mad there. All right, continuing, example 21 here. It says, perform the operation, express your answers as a single fraction. So I have a y in the bottom. We can't add these two dudes until you get another y in the bottom. So I'm going to multiply this product, this xy, by y over y. And when you do that, you get 1 over y plus xy squared over y. And now we can go ahead and just add these two dudes up. 1 plus xy squared over y. And yeah, guys, it's really that simple. See, so hopefully you're having a really good time. Maybe, you know, do some of these with your grandparents, because they're kind of like little puzzles. And sometimes, you know, like grandparents like doing little puzzles and stuff like that. So maybe you can teach them, and maybe during the process, they're like, oh yeah, I want to do this. All right, so this one says simplify the following expression. So the way to get there, guys, the way to simplify this is you got to factor out. So x squared plus 2x minus 63. So here's an easy way to do it. Two numbers that multiply to give you 63. Obviously, it's going to be negative. So you're going to have one that's positive, one that's negative. But that the difference is 2. So 9 and 7 is 63 when you multiply them. And the difference between 9 and 7 is 2. So x 9 and then x, what did I say, 7? All right, I didn't put the plus or minus in there, guys. I have a plus here, so I need the larger number to be a positive. So the 9 is a positive and the 7 is a negative. Same thing in the bottom. Two numbers that when I multiply give me a 70, a negative 70 to be exact. And I want the difference to be 3. So that means, what's that, 10 and 7? 10 times 7 is 70. And the difference between 10 and 7 is 3. So I'm going to write x plus 10 and x minus 7. All right, so there it is. Why did I make the 10 positive? Because I need the denominator to add up to a positive 3x. If you're having issues with factoring, guys, please let me know, and I can make another video on how to factor. So here we go. Now we just delete the common factors that I have. If I have something in the top that's the same or equivalent as what I have in the bottom, and you do, you have this x minus 7 here. So you can just cancel those out. So later on when we talk about graphing rational functions, you're going to say that you have a whole at x equals 7. But right now we're not talking about that. So this simplifies to x plus 9 over x plus 10. If this had a y equal on front, you would say that you have a horizontal asymptote at 1, vertical asymptote at negative 10, and a whole at 7. But that's just, you know, when we get there, we'll get there tomorrow. All right, I believe that is it for that one. All right, let's continue with this one, guys. We're doing the same thing. So two numbers that when I multiply give me a negative 72, but that the difference is 1. So I can already see, and look, it's the same in the top and bottom. So it's going to be the same numbers probably because I see the 17 in the bottom. So the two numbers are 9 and 8. 9 times 8 is 72, and the difference between 9 and 8 is 1. And then when I sum 9 and 8, when you add them up, you get 17. So this is not a video on how to factor, guys. I'm assuming you already have some skills when it comes to factoring. If you have issues with factoring, guys, I can always make a video on how to factor. So this is not it. I'm just kind of going through the steps real quick. So here we go. We said x minus 9, x plus 8. The reason why I chose the 9 to be negative is because I need to sum them up to be a negative 1. So the negative has to be the larger magnitude number. And on the bottom, it's going to be x plus 9, x plus 8. So from there, what factors are equivalent in the top and bottom? The x plus 8s. So we have x minus 9 over x plus 9. And there it is, guys. All right. So here again, we're going to need two numbers that multiply to give you a 21, or I guess a negative 21 if you want to be technical, and that the difference is 4. Well, that's going to be 7 and 3. So I'm going to write x, 7, x, 3. I need the 7 to be negative because I have a negative 4 there. So I need the larger magnitude to be the negative. And in the bottom, this is known as the difference of squares. So let me write the formula for difference of squares. So here it is. So there's my difference of squares. So I'm going to write x minus 7, x plus 7. X times x is x squared. 7 times 7 is 49. And then we just cancel what the factors are that they have in common. I have an x minus 7 one on the top, one on the bottom. So when I do that, now I just have an x plus 3 over an x plus 7. Oh, that plus came out kind of funky, huh? And there it is, guys. All right, let's keep going. Example 25. So we're flying through this. I don't think you guys will have any issues here. Again, x squared minus 16, that looks like the difference of squared. X times x is x squared, 4 times 4 is 16. So I can write the numerator as x minus 4, x plus 4. And on the bottom, it looks like you can only factor out an x. So x, and then I'm going to have x plus 4. So these might be easier than the ones we did previous, right? So maybe we should have started with these first. So the x plus 4's cancel out. And you just have, and I guess I should go back to red here, x minus 4 over x. And that's it, guys. Leave it alone. Same thing here. Factor out an x in the numerator. So if I factor out an x, I'm going to have x plus 5, and I'm dividing by 2x squared. So because I have an x squared in the bottom, I can cancel one of these x's with one of those. So now what we have is x plus 5 over 2x. And that's it. All right, example 27. Oh, I put a lot of white space there. I don't think we're going to need all that white space, but we'll see. So the way to combat these guys is to go slow and to factor everything out where you can. So I'm going to try and go as slow as I can, guys. So the first thing I see is 6 here, and I see 216. And I know that if I factor out a 6, 6 goes into 216 36 times. And if you don't know that, just use a calculator. 216 divided by 6 is 36. And I know that the calculator can simplify all this, guys. Try to do as much as you can by hand. And then just use the basic 4-function calculator, to figure out like how many times does 6 go into 216 type of deal. So here we go. I factor out a 6, and I'm going to have x squared minus 36. I'm going to leave it like that. I know that x squared minus 36 is the difference of squares over, let's see, x squared minus 2x minus 48. Two numbers that multiply to give me negative 48, but where the difference is negative 2. Well, that's 8 and 6. 8 times 6 is 48, and the difference between 8 and 6 is 2. So I'm going to write x8, x6, and then we want the negative, we want the larger magnitude to be negative. So the 8 has to be negative and the 6 is positive. Dot, and then you see how I have 64 minus x squared right there, guys? I'm going to factor out a negative. So you factor out a negative, you're going to have that x squared in the front, like so. And maybe this is easier for you guys. You don't have to do this if you don't think it's necessary, but I think it's easier for you guys because you guys have been working with x squared in the front and the positive all your life. So just, leave it like that right there so it's easier to see. And then in the bottom, two numbers that multiply to give you 40, but add up to 13. Well, that has to be 8 and 5, right? 8 times 5 is 40, and 8 plus 5 is 13. And they're both going to be positive. So x plus 8, x plus 5. And then again, I'm going to factor out a negative, and I'm going to write x plus 5. And then let me know if you see any mistakes. All right, so let me check if I have any mistakes. I don't see any. If you do find some, let me know in the comment section. All right, so here we go. Let's start. I have an x squared minus 36 on the left, right here. And I have an x squared minus 36 right there in the bottom, in the very last term there from the product. So that one's out. And then let's see what else I can cancel out. I guess I see an x plus 5, and I see an x plus 5. Now, don't forget that negative there, guys. So here's what I'm going to do. I'm going to circle these already. Negative times a negative. Negative times a negative is a positive. So I'm just not going to write negative anymore. So here's what I have. I have, let's see, I have that 6 there, and I have x minus 8, x plus 6, dot, and then the x squared minus 64, that's the difference of squares. So I'm going to write x minus 8, x plus 8, over, and then I still have that x plus 8 here. I'll cancel that in a little bit. Dot, and actually, no, I have nothing else over there anymore, so that's it. All right, so here we go. Let's see if we can keep canceling. I have an x plus 8, x plus 8. I have an x minus 8, x minus 8. And I think we are done. So all I have in the numerator is a 6, and in the denominator all I have is an x plus 6. So there it is, guys. Yay, we did it. See, these are like little puzzles. So I'm sure your grandparents or maybe your parents or guardians, maybe they would like this, guy. So, maybe show it to them and maybe they'll have a good time. All right, here we go. So now if you're wondering why we're doing this, we're not just doing this just to go through the motions. We're gonna be graphing rational functions pretty soon. So we need to be able to, accomplish this task first before we can start graphing. And then why do we graph? Well, because in real life, there's always different models that fit different situations. Correct? Or the coronavirus is expanding exponentially, so that's why you cover exponential functions, guys, so you can have an idea of what's going on. All right, I see a division sign there, so I'm gonna do keep change flip. So I'm gonna rewrite everything, and then I'm gonna factor out where I can. So let's see, 2 over x plus 3, nothing there. Dot, I'm gonna factor out a negative in the numerator, and I'm gonna write x plus 5 over, and on the bottom I can factor out an x because I see x cubed, 2x squared, and 15x. And then I'm going to be left with x squared plus 2x minus 15. And in a little bit, I'll go ahead and simplify that. Dot, and I'm going to flip these guys. So I'm going to write 9 minus x squared over negative 2. All right. Let's see if we can continue and work some stuff out here. So I'm going to write 2 over x plus 3, nothing there. Dot, negative in the front, x plus 5 over, in the bottom, I'm going to write x, and I'm going to write, let's see, two numbers that multiply to give you 15, but the difference is 2. Well, 5 and 3, right? So I'm going to write x plus 5, x minus 3. 5 times 3 is 15, and the difference between 5 and 3 is 2. Are we still okay, guys? Okay. So now, and I still have this guy right here, right? Dot. So now I'm going to factor out a negative, and I'm going to write x squared minus 9 over negative 2. All right. So I'm going to circle both of these. Negative divided by a negative is a positive, so I'm not going to write that negative there anymore. All right. So now, let's go ahead. I'm going to expand one more time. 2 over x plus 3. And no, I'm not insulting your intelligence, guys. You guys can go ahead and take shortcuts. It's not a big deal. Negative in the front, x plus 5 over x parenthesis x plus 5, x minus 3. Dot. I'm not going to write the negative anymore. The top is the difference of squares. So I'm going to write it as x plus 3, x minus 3 over 2. All right, here we go. I have a 2 in the numerator and a 2 in the denominator. That's out. I have an x plus 3 in the denominator and an x plus 3 in the numerator. That's out. I have an x plus 5 in the numerator and an x plus 5 in the denominator. That's out. I have an x minus 3 in the denominator and an x minus 3 in the numerator. That's out. So the only thing I see I still have a negative. So negative, and it looks like negative 1. And in the bottom, it looks like I just have this x here, this lone x. So there it is. All that simplifies to negative 1 over x. See, guys, wasn't that fun? I heard you. One of you said no. That's not cool, guys. All right, let's continue. Again, I see a division symbol again, so I'm going to do keep, change, flip. I'm going to factor out where I can initially, and then we'll keep going from there, guys. So let's see. I'm going to factor out an x first. And yes, if you already see it that it's x squared minus 64 and you want to do x minus 8, x plus 8, go right ahead. I'm just trying to show as many steps as I can initially here. X squared minus 64, close, over, again, two numbers that, well, first let's factor out an x, right? X, and then x squared minus 13x plus 40. Yes, if you want to factor this out already, go ahead, guys. Like I said, I'm just trying to show as many steps as I can here. I'm going to factor out a 2, and I'm going to have x squared minus 3x minus 10, because I noticed that all of them were even, over, and on the bottom I see that all of them have an x, and they're all even, so I'm going to factor out a 2x. So I'm going to have x squared plus 4x minus 32. Okay, I hope we're still good, guys. I'm going to put a little dot there. And then let's see, I'm going to keep change flip, right? So now on the top, I'm going to have x squared minus 16 over, I'm just flipping these because I changed the division side to a dot, to a multiplication, over x squared plus 6x plus 8. All right, I hope we're still good. Let's continue. So now I'm going to go ahead and cancel. I see this 2 and that 2. I'm going to cancel those right off the bat. I see that x and that x. I'm going to cancel those right off the bat. Now I'm going to go ahead and expand where I can. X squared minus 64, that's the difference of squares. So I'm going to write x plus 8, x minus 8. In the bottom, two numbers that when I multiply give me 40, but add up to 13 or a negative 13. So that means they're both going to have to be negative. So it's going to be, what's that? 8 and 5, 8, 9, 10, 11, 12, 13. Yeah. So x minus 8, x minus 5. Okay. Are we still good, guys? Dot in the top. Let's see. Two numbers that multiply to give me a negative 10, but add up to a negative 3. So 5 and 2 again. But this time the 5 is negative. X minus 5, x plus 2. Over, and then two numbers that multiply give me 32, negative 32, that add up to 4. So that means I want the difference to be 4. So it has to be 8 and 4. 8 times 4 is 32. And the difference between 8 and 4 is 4. So I'm going to write x plus 8, x minus 4. Oh, sorry, guys. I'm going to turn off my phone here. I wasn't expecting a text on a Sunday morning here. 8 times 4. 8 times negative 4 is negative 32, guys. And the difference between 8 and 4 is a positive 4. So there it is. And then x squared minus 16, that's x plus 4. X minus 4. Over. And on the bottom, let's see. What two numbers multiply to give you 8, but add up to 6, 4, and 2. X plus 4, x plus 2. 4 times 2 is 8, and then 4 plus 2 is 6. All right, now we're ready. So let's see. X plus 8, x plus 8. I see those two, so I'm going to cancel those. I see an x minus 8 and x minus 8. And then I see an x minus 5 and x minus 5. Let's see, I see an x. Oh, look, I almost made a mistake, guys. This x there goes right there. I think the text message distracted me. All right, let's continue. X plus 2, x plus 2. X minus 4, x minus 4. X plus 4, x plus 4. So this one, let's see, in the numerator I have nothing, so 1. And in the denominator I have an x. 1 over x. So this one is a positive 1 over x. So we almost, well, I guess I almost lost that, guys. My bad. I hope you guys weren't screaming, Chavez, the x, put it back in, blah, blah, blah. So there you go. I fixed it. I saw it. I'm going to blame it on the text message. Who was it? Oh, okay. Okay, I usually don't chat, but I usually don't get text messages on Sundays. All right, we're good. We're good. Someone just got the coronavirus. No, I shouldn't joke around like that, guys. I promise you it wasn't anything with that. Everyone's healthy here. All right, let's continue. So now we got these nasty complex fractions. They're not that bad, actually. Maybe we should have put these earlier. What we're going to do is we're going to find a common denominator in the numerator and a common denominator in the denominator, if that makes sense. And then we're going to go from there. So in the top, what's stopping me from adding these two dudes up is this guy. So I need to multiply that by x over x, and then I'll have an x squared. So so x over x squared plus 1 over x squared all over. And then in the bottom, I'm going to multiply the 1/3 by 3 over 3, and then I'll have a common denominator in the denominator, if that makes sense. X over 9 minus 3 over 9. So now what I have is x plus 1 over x squared divided by x minus 3 over 9. And now you can do the keep change flip, which, you guys tend to like that. X plus 1 over x squared times 9 over x minus 3. That's not necessarily my favorite route to do these, but that's fine. I'm not going to try and change the way you guys think if that's how you guys learn this in junior high, which is, I'm perfectly okay with it. And then just, did it say to show my factors? It was factors shown. Okay, since it says factors shown, guys, leave everything factored out. 9x plus 1, and then x squared, x minus 3. And there it is, because it says factors shown there. So let's keep going. again, this way guy looks like it wants us to show the factors, so that's fine, no big deal. So again, I'm looking at this, and I'm going to multiply the x over 2 by 2 over 2, so we can get the denominator to be 4. And I'm going to multiply the bottom here by 2 over 2, so I can get that guy to be 4. Ooh, there might be something special that comes out on this one, I'm not sure. So here we go. So on the top, I have x squared over 4 minus 2x over 4, all over, let's see, 2 over 4 minus x over 4. So let's see what we got here. X squared minus 2x over 4 over 2 minus x over 4. You are perfectly okay if you cancel out those 4's right now, which is my preferred method. But I know some of you guys don't like that because you want to keep consistent with what you've been doing. So let's just continue. X squared minus 2x over 4 times, and then keep change flip, 4 over 2 minus x. So now we can see that these 4's are going to cancel out. And then you're going to have, let's see, x squared minus 2x over 2 minus x. And it does say to show all factors. So on the top, I can factor out an x. And I'm going to have x minus 2. And on the bottom, I have 2 minus x here. And don't stop right there, guys. Recognize that if I factor out a negative 1 in the bottom, I'm going to have an x minus 2. So I'm going to write x minus 2, and then I'm going to put a negative 1, I guess, if you want to show that 1 there. What happened there? X minus 2. So notice, now the x minus 2's cancel out, and you just have x divided by negative 1. Well, x divided by negative 1 is just negative x, guys. So don't leave it as x divided by negative 1. I mean, that's technically correct, but I prefer just write negative x. I don't see any errors, and I think that's it. All right, let's keep going. These are the simple ones. Do you guys want me to skip this one? Because it's just the same. Yeah? Okay. No, I didn't hear anyone, so I have to do it. So times 2 over 2 times 3 over 3. So 2 times 2 is 4x. 2 times 3 is 6 plus 3 over 6. So 4x plus 3 over 6. And you're done with that. Again, on this one, common denominator. Maybe it's not as simple as that one there, but this one, go ahead and multiply by x plus 9 over x plus 9. Remember, x plus 9 over x plus 9, that's just 1. So you're not changing anything. And then the left term, multiply by x over x. When you do that, you're going to get 5x over x squared plus 9x plus, and let's see, distribute. 5 times x is a 5x. 5 times 9 is a 45. And then over x squared plus 9x. I don't see anything saying about have it in factored form. It just says to fully simplify in our own fraction. So 5x plus 5x is a 10x. So 10x plus 45 over x squared plus 9x. And there it is, guys. All right. If I'm going too fast, just pause it and rewind it. All right, so this one might be tricky to some of you guys. Multiply that 7 here by x minus 2 over x minus 2. So let's see what we got. 2 over x minus 2 minus, so there's that minus, 7x minus 14 over x minus 2. Now, I still haven't distributed the negative, guys. So here's what we now have. The denominators are the same here. So 2 over x minus 2 minus, let's see, I'm going to put a plus here because I'm distributing the negative now. 7x plus 14 over x minus 2. So that negative, that's a long negative there. That negative there belongs to that 7x here. So now, when I combine all these, so let's see, negative 7x plus 14 and 2 is 16 over x minus 2. Now, quick warning. Let me make sure that's 7x here. A lot of professors actually hate the negative to be in the first term. So a lot of people probably would have written 16 minus 7x. I'm okay with it, guys. Just make sure this negative does not start floating. This is not, like if you do this, negative in the front and you write 7x plus 16 over x minus 2, that is wrong. Because now you're telling me that the whole expression is negative like that. So that's why sometimes that negative there is an issue. Now, because the assignment is digital, I don't think it'll be an issue because you'll just type a negative in front of the 7 there. But that's just something for you to keep in mind, guys. I had a professor who was pretty picky about that, and I understand why. I understand why he was rowdy about it. But yeah. All right. One more, guys. This is the last one. I'm going to multiply this right one here. You need a common denominator to go ahead and take care of these. So I'm going to multiply that by x over x. Multiply this one by x minus 3 over x minus 3. And I'm going to go ahead and take care of, I'm going to do the foiling here on the side, guys. X minus 3 times 3x plus 5. I mean, I guess I could do it really quick, but I better not. So I better just go ahead. Look, x times 3x, that's just 3x squared. X times 5, that's a 5x. Negative 3 times 3x, that's going to be a minus 9x. And then negative 3 times a positive 5, that's going to be a minus 15. So 3x squared, the difference between 5 and 9 is 4. The 9 is larger, so minus 4x minus 15. So hopefully you guys are okay with that. All right, so now I'm going to come back over here and I'm going to write it, guys. So I'm going to write 3x squared minus 4x minus 15 over, and then x times x, that's just x squared. And then x times 3, that's minus 3x. Plus, let's see, 7x over x squared minus 3x. And the denominators are the same, so now I can just add them up. 3x squared, the difference between 4 and 7, 4, 5, 6, 7, is 3. The 7 is larger, so plus 3x, and then minus 15, all over x squared minus 3x. And there it is, guys. I don't see any issues there. Let me know if I went too fast. Maybe see if you can check it out one more time, guys. And if you guys have any issues with factoring, let me know. Just send me a message on Google Classroom or something like that, and I can always do this again. All right, I'm going to go ahead and upload this, guys. Well, if you're seeing it, it's probably already been uploaded. I would like, if it's cool with you guys, I would like a thumbs up. If not, that's fine. But yeah, so check it out, guys. And tomorrow I'll probably be putting up notes 4, which is graphing rational functions. So we might have issues on that one, so I'll see if I can go slow on that. All right, talk to you guys later. Bye.